So today we're going to talk about some basic logic gates. Something like OR gate, AND gate, NOT gate. So let's start with the OR gate. Let's say if we have a circuit, something like this. There's a switch here, then another switch here, and we get light after the switch. Let's label this as A, this as B, this is the output. So either A is closed, so the light will come on, or B is closed, the light will come on. So the Boolean expression for this will be y equal to A plus B. If we need to build the truth table, since we have two inputs here, so inputs will be A and B. So we have two inputs, and for the state A will be have 0 and 1. 0B will also have 0 and 1. How many combinations for that? So we could have 0, 0. If this is A, this is B. We also have 0, 1. So when A is 0, B is 1. A is 1, B is 0, A is 1, B is 1. So that's the truth table. That's how many inputs we have. Since we have two inputs, so the combinations will be based on the inputs number. So if we have inputs as n, the combination will be 2 power to the n. That's how many combinations we have. So for the output, say this is a y. When it's 0 and 0 both open, the light will be off. And when 1 is on, so when B is closed, it will be 1. This light will come on. Either A is 1, the light will also come on. Both A and B are closed, the light will also come on. So that will be our truth table for the OR gate. So it will be either 1 is closed, the light will come on. So 1, just need one input is 1, and the result will be 1. So that's kind of a 2 inputs OR gate. What if we have 3 inputs? So let's say if we have 3 inputs OR gate. Three inputs OR gate. Let's say the input will be A, B, C, and the output is a Y. So what was that B? So we have 3 inputs, so the combinations will be 2 to the n, which is 2 to the 3, which is 8. So let's build the truth table for it. A, B, C, Y. So we will have, so let's start from 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and also 1, 0, 0 will be next. So basically we keep adding 1 to the last digit or last bit. So 1, 0, 1. This one will be 1, 1, 0. And the last one will be 1, 1, 1. So if in decimal, that will be start from 0, 1, 2, decimal. And that will be 3, 4, 5, 6, 7. So 0 to 7, which is 8 numbers. That's why we have 8 combinations. So for OR gate, let's say the Boolean expression is still y equal to A plus B plus C. So which one gave us 1, we will get the result of 1. Since the first one's 0 and the The rest we all have ones. So this is a one, this is a one, these are ones, one, 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 one here. So when we see one, that will give us the result one. So those are all ones for the rest. Since it's addition, so 1 plus 0 will give us 1. So whenever we have 1, the truth table will be 1 for the output. Now let's talk about the AND gate. So for the AND gate, basically it's in series. There's one switch here, and then another switch here, and the light is right after it. So let's say this is A, this is B, this is Y. So we need both switch closed in order to get the light to come on. So the Boolean expression for the AND gate will be Y equal to A times B. So we need both closed in order to give us 1. So let's build the truth table. So for the combination of the out inputs, that will be also 2 to the n. So here we have 2 inputs, so 2 to the 2, so that will give us 4. So let's say this is A, B, Y. Just build the truth table for it. So 0, 0, 0, 1, 1, 0, and 1, 1. Since that's multiplication, so 0 times 0 will give us 0, 0 times 1, 0, 1 times 0 will give us 0, 1 times 1 is 1. So this is the truth table for 2 inputs AND gate. What if we have three inputs? So for 3 inputs AND gate, same thing. Let's say we have inputs A, B, C as inputs, and Y is the output. So same thing, the Boolean expression Y equal to A times B times C. That's still the Boolean expression. Since we have 3 inputs, so n equal to 3, the combination for the truth table will be 2 to the 3, which is 8. Same thing, we start from 0. So let's just put a table here, A, B, C, Y. Just get going. So we'll have start from 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, and 1, 1, 0. So last one will be just add 1 to C, 1, 1, 1. Same thing for the decimal, it will be 7, 0, 1, 2, 3, 4, 5, 6, and last one 7. So 0 to 7 is 8. So we have 8 combinations. And the Boolean expression Y equal to A times B times C. So 0 times anything will be 0. So whenever we have 0, it will give us 0. So we start from here, we have 0, 0, 0, 0, 0, 1, 0, 0, 1, 0 will give us 0, 0, 1, 1 will give us 0, 1, 0, 0 will also give us 0, 1, 0, 1, 0, 1, 1, 0 is 0, 1, 1, 1 is 1. So basically we need, if we draw the your switch diagram, so we have 3 switches, these in series, that's a light here. All the switches need to be closed in order to turn on the light. Either one is open, so we say switch closed is 1, and switch open is 0. So we need all switch closed. In order to get 1. That's the Boolean expression or the output for the AND gate. Now if we have a NOT gate, NOT gate basically is kind of invert. So if we have A as the input, what's the output? Output would be A bar, not A. So Y equal to A bar. So for the NOR gates, the input is just one input. So let's say we have A. A could be 0, could also be 1, and the output be not A bar. Not 1, not 0 is 1, not 1 is 0. So that's the truth table for NOT gate. Sometimes we could also have the combination circuit or combination logic. Logic gates. So basically we kind of have either OR gate, NOR gate. They are kind of in one circuit together. Let's say if we have something like this, we have AND gate here. Or the symbol for NOT gate will be something like this. And for AND gate, it will be something like this. That's AND gate. Depends how many input this one to A, B, C, that's Y. And for 2 inputs for AND gate, it will be something like this. It's a straight line curve, A, B, that's Y. For OR gate, it will be 2 inputs, something like this. So that's more curved. Let's do this. Oh, sorry, that's not a line, it's something like this. That's usually side. Go back to the pencil, so that's the OR gate. A, B, Y. So something like this. There's a curve here, there's another curve here. A, B. So if we have AND gate here and NOT here, outside that's C1. Let's move this over a little bit. There's another AND gate. I go to the OR gate. There's a NOR gate here. Then C. So let's say we have this is A, it's B, C, Y. Now we need to get the expression for Y. What will be Y equal to? So let's start from the left to right. We have the logic gates like something like this. So this will be A, and this is a B here. Not B will be B bar, not B. So the input for this guy will be B bar here. Do this B bar, so we also have B bar here and C here. So that's AND gate, so that will give us, after the AND gate, the output will be A times B bar. Here will be B bar times C, and this is OR gate. So here it's the same thing, just copy this guy, A times B bar. This will be B bar times C as the input. This output basically need to add the 2 inputs, which is this guy and this guy. This is the first one, this is the second one. So Y will equal to A times B bar plus B bar times C. So this is a Boolean expression without simplified. So usually when we work on the combination logic circuit, we just start from the left, go through each input, and get the output update. Just keep going until we get the final result. So if we want to simplify it, we can pull out the common factor, which is B bar times A plus C. And for the truth table, we have something like this. So we have 3 inputs. So the combination will be 2 to the 3, which is 8. So I say A, B, C, Y here. Just build the truth table for it. So we start from 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0. The last one will be 1, 1, 1, which is 7. So that's how we build the truth table. Now we just need to plug in the number to this Boolean expression here. If we have all zeros, so it will be 0 plus 0, which is 0. So basically whichever A plus C, if it's 0, that will give us the output 0. Let's see how many combinations do we have. So A plus C is 0, basically it's A0, C0. So we have it, let's just kind of change the color here. So we have A0, C0, which is this guy, this one, this one. And that's it. So we would have Y as 0 on this one, 0 here. And then the other one is a B bar. So B bar, when B bar is 0, that will also give us Y equal to 0, which means B is a 1. That will give us Y equal to 0. So we just need to pick up B equal to 1, which this is. That will give us 0. And then for the rest, we just need to work out the 1. Let's see. So we have 0, 0, 1. So when A is 0, C is 1. So 0 plus 1, which is A plus C, times B bar, which is 0 plus 1 times B bar. B is 0, B bar is 1, so that will give us 1. So the result will be 1. This one is A plus C times B bar. Same thing should also give us 1 plus 0. B bar, B is 0, B bar will be 1, so that will also give us 1. A plus C here. Both high is high times B bar. B is 0, B bar will be 1, so that will also give us 1. Now we have all the numbers, so that will be 0, 1, 0, 0, 1, 1, 0, 0. So if we don't want to just figure out zeros and ones, we could just plug in the number to this Boolean expression. That kind of like the same way we do the math. Now we get the truth table, so that will be 0, 1, 0, 0, 1, 1, 0, 0. That's how we work it out. Okay, thank you for